Yes. A very good afternoon, everyone who are present today. And many of you, some people know me, and some people are like not familiar with me. So my name is Umi Nishar Banu. I'm a consultant trainer in Sankhyana. So I have been teaching data science as well as SAS programming language here.
Hello, ma'am.
So yes, hello Divya.
Ma'am, I told you that give me you give me the recording after the meeting? Send me the recording.
It will be uploaded in the YouTube. You can just go take a look there.
Okay, ma'am. Thank you.
Yes. Okay. So today's topic of discussion, what we are going to do is the advanced functional exploratory data analysis using Python. So we have seen lots of exploratory data analysis recently. If you go outside and take a look into the different blogs or articles, whoever is writing, we have seen that many of them are trying to give the exploratory data analysis using Python programming languages more out there. So when it comes to the exploratory data analysis, we just know the basic things how to do the exploratory data analysis, but we can also have some advanced functional EDA in using our Python so that we can use that for the all of our data separately. We don't have to do the same step again and again, so that we are deriving a function and then using that function and applying in our data which is required to do our work. So that is what we are going to see practically today. Practically as well, and few theoretical concepts also will be covered regarding what is EDA and everything. So moving to our agenda of today's session, it's like we are going to see the approach of the EDA exploratory data analysis here, and focus on the philosophy behind the exploratory data analysis and the advanced functional techniques in the EDA is also what we are going to see. So here, why we have these three topics which we are going to cover today is nothing but we all know that the data from the experiment or the research are generally collected in a spreadsheet or a database form, right? So most commonly with one row per experimental subject or one column for each subject, identifiers will be there, outcome variable will be there, and the explanatory variable can also be there in that particular study. So each column which is having, it can contain the numeric values for a particular quantitative variable, or the level for the categorical variable can also be there. Some more complicated experiments require more complex data layout also. We cannot judge what can happen there. So people are not very good at looking at the column of numbers or a whole spreadsheet, then determining the important characteristics of the data over there. So they find looking at the numbers to be very tedious, right? Obviously, when it comes to the numbers, when we are taking a look into numbers and we have lots of data rows in our spreadsheet, then it will become very tedious for us, and sometimes it becomes boring, or sometimes it will be very overwhelming. So the EDA or this exploratory data analysis have been devised as an aid in this kind of situation. Okay, to in this kind of situation, so that is the reason we are going to see these approaches of the exploratory data analysis, and then focus on the philosophy behind this EDA, and we are going to see the advanced functional techniques in the EDA. So moving to our first section, that is approach of the exploratory data analysis. So EDA is a kind of an approach, or we can say it is a philosophy for the data analysis that employs a variety of techniques, sometimes mostly graphically also. Okay, most of the time the EDA will be done graphically, especially in the Python programming language, to maximize the insight into the data set. So when it, even with the numbers, or even with the numbers or the mean value or whatever it is, we sometimes we feel like a bit of confusing also. So we will be taking the graphs there, mostly graphical representation, with using the data visualization, we explore it in a very easy way. So we can what can we do with this EDA is we can uncover the underlying structure of the data. We can uncover like we can extract the important variables. I can test the underlying assumptions in my data. I can detect the outliers or the anomalies which where the data is deviating from my mean value of the data. I can develop the different models in the data. I can develop and I can determine optimal factor settings for my data. So that is the reason we have the approach of the exploratory data analysis with us. So here, if I ask you all, what is EDA, that is exploratory data analysis. Okay, if I ask you what is EDA or what is exploratory data analysis, it's like when it comes to EDA, remember how good you are at this will make a huge difference professionally when it comes to your career, when you're choosing it for a data analyst or a data scientist. Okay, when you are good with your exploratory data analysis, you're going to make a huge difference in the career which you're choosing professionally. So here, if you ask, if you just let's take an intuition here, or you can imagine your wolf pack is deciding to watch a movie you haven't heard of at all, and then there are absolutely no debate about that. So it will lead to a state where you can find yourself puzzled, like with lots of questions you will get in your mind which needs to be answered, so that in order to make a particular decision, so being a good Shiftian, like the first question you would ask is what is the cast and the crew of the movie, right? You will have that question. Somebody is taking you to that particular movie. You should have an understanding what is the cast and crew of the movie. As a regular practice, you would also watch the trailer of the movie on the YouTube or wherever it is, wherever you can get it. And furthermore, you would also find out the ratings and the reviews the movie has received from the audience, right? On the basis of this only, you are deciding to watch that movie or not. So whatever investigating measures you would take before finally buying a popcorn for your particular clan which you're going with in the theater, so it's nothing but what the data scientists in their language they call it as a exploratory data analysis. Okay, in a simple way. So before you plan buy a popcorn and go sit in the theater, you just check the YouTube, you go check the reviews, you go see the trailer, and what is the cast and the crew, who's your favorite actor, favorite actress, so everything you're going to check. So you're doing some exploration outside there before you watch that movie. So in the same way, the data scientist language, that is called as exploratory data analysis. So the exploratory data analysis, it refers to a critical process like performing initial investigations. So they are the initial investigations on the data, so as you can cover the patterns in that, you can discover the different patterns, you can spot the anomalies, you can do some test hypothesis also. Sometimes you might have some question on your data, you might have some hypothesis on your data or assumption with your data, so you can test the hypothesis and prove whether the hypothesis is accepted or it is rejected, and to check the assumptions with the help of the summary statistics in the data and graphical representations in the data. So it is a good practice to understand the data first and try to gather as many insight from it. So that is what EDA is going to do. So that is all about making the sense of the data in your hand. With the help of exploratory data analysis, you're going to make some sense for that data, right? So only if you have a proper sense for data, you are going to extract the features from that particular data, and before getting them dirty with it. So we are removing the dirty data and we are cleaning the data also by using this exploratory data analysis. So before I clean my data, I will have to do this exploratory data analysis. So only when I explore, I can find out what is the anomaly there, what should I clean in that data. All the things I can explore in that particular data set. That is what we are doing in the exploratory data analysis. And when it comes to the focus and the philosophy behind the exploratory data analysis, so what is the focus and the philosophy? So the focus is nothing but here you are going, the EDA approach is precisely that, an approach which is not a set of techniques, but an attitude or a philosophy about how a data analysis should be carried out. Okay, so that is the focus. So how a particular data analysis should be carried out is your focus in this EDA, and the philosophy in this EDA is, in the EDA approach is nothing but, for the EDA approach in the data analysis, that postpones the usual assumptions about what kind of model the data follow, with more direct approach of following the data itself you're going to do, which is going to reveal its underlying structure and the model. And this EDA is not a mere collection of techniques. You should try to understand that one. EDA is a philosophy as how we dissect a data set. Okay, how we dissect a data set. And then we are going to what we look for in the data set, how we look in the data set, how we interpret in the data set. So it is true that this EDA is heavily using the collection of techniques that we call the statistical graphical representation, but it is not identical to only the statistical graphs. Okay, that also you should understand. We are not just only sticking to the statistical graphs here, rather we are also using the techniques by the statistical graphs. That is another point to be noted when it comes to the focus and the philosophy behind the EDA. And the next question when it comes to the exploratory data analysis is why this EDA is a significant pick in the data science. Only when it comes to the data science, why it is a very significant pick when it comes to the data science. So the primary objective of EDA is nothing but it is going to assess the look at the data before you are giving any rise of, or before you're going to give any interference from the data or insight from the data. So it enables you to observe any mistake which is there in the data. It is going to make you like it will enable you to observe a noticeable mistake and a reasonable mistake in the data, and also it will make you to understand the structure within the data by distinguishing between the anomalous events or the outliers in the data. And you can also find sometimes you when you are exploring the data, you can also find a kind of a fascinating association among the variables, each of the variables here. Variables in the sense you can just take it as a columns. So those columns you will be it will be a kind of some association between the variables. That is what we want, right? Data science is nothing but we are just going to find out the relationship between the variables there, and we are going to predict the future based on the relationship between the data. So a data scientist employ this EDA, exploratory analysis, to ensure the outcomes so that they produce what they are going to produce are accurate and acceptable to any business decision which is desirable. Findings are obtained and the objectives are very clear in that. And this EDA also will help the stakeholders by assisting them by confirming they are confirming they are inquiring about the moral questions there. And the EDA sometimes it helps to answer the questions about the categorical variables also. So we were not only sticking with the descriptive statistics. When I say only with the numerical variables, exploratory data analysis EDA will also help us to question about the categorical variables, the standard deviations, and we can also the confidence intervals between the variables can also be found out very easily. So once you are going with this EDA and this EDA is finished, the ideas are brought out. So its characteristics employ like more sophisticated data analysis and for modeling or encompassing the machine learning as well. So when it comes to machine learning, your data should be clean and it should be proper without any missing values, without any outliers in your data, without your data should also have a normal distributed data, so that you are going to train your machine so that it is going to predict the future. So when you are going ahead with the machine learning, your EDA is very, very important. Your exploratory data analysis is very, very important, where it is going to improve the understanding on your data, identify the patterns and discover the errors in the data. That is, when you have your dirty data, it is going to explore the dirty data, find where is the mistake, and you're going to solve it by cleaning the data. So that is EDA. That is the reason it is a very good scientific pick in the data science. And then the next one is the four fundamental kinds of exploratory data analysis. So we are going to see the four fundamental kinds of data analysis, exploratory data analysis here. So the first one is the univariate non-graphical data analysis. Okay, like the four, let me just mention the four. What are the four kinds of EDA? That is nothing but univariate non-graphical, univariate graphical, multivariate non-graphical, and multivariate graphical EDA is there when it comes to the fundamental kinds of EDA. So the first one which we are going to see is nothing but what is univariate non-graphical exploratory data analysis. So univariate non-graphical exploratory data analysis is nothing but, so it is most straightforward analysis. Okay, it is a most straightforward aspect for the data analysis, where the data is analyzed, which is consisting of barely one variable. Okay, think that the data is consisting of barely one variable. Since it's a sole variable, only one variable, it does not negotiate with the connections. We are not going to look for the different connections between it, only the one variable we are going to consider there. So the univariate analysis primary objective is to interpret the data and discover the structure that occurs with that particular data, within that particular data. So that is the univariate non-graphical analysis. When it comes to univariate graphical analysis, so here you have univariate graphical. So what is this univariate graphical? This is a non-graphical technique. So univariate graphical, wherein sorry, this is not a non-graphical technique. So this is a non-graphical, the non-graphical techniques which was there above, that is univariate non-graphical technique, do not deliver an entire image of the data which you're dealing with, right? But like visual methods are thus like employed with the help of the univariate graphical, that is stem and leaf plots are there. So with the univariate graphical, I can employ the graphical representation with stem and leaf plots, like which will exhibit all the data values and the pattern of the measurement in them. Okay, the stem and leaf plot will exhibit all the data values and the pattern of measurements. Then comes the histogram graphs. So histogram graphs, it is a kind of a bar plot in which every bar amplifies the frequency or the count or the percentage of the trial for the spectrum of the values which you are looking for. And then you have the box plots. So those box plots, like which graphically it will portray the minimums phi number overview, are the first quartile, median, followed by the third quartile and the maximum. So that is the box plot description. And then we have the multivariate non-graphical analysis. So EDA, not analysis. We can also say it as analysis, multivariate non-graphical exploratory data analysis. So when it comes to this one, multivariate is nothing but multiple variables. So earlier you saw univariate, single variable, sole variable you're taking. Here multiple variable data arises from additional than one variable, more than one variable, where these EDA methods usually exhibit the connection between the two or more extra variables of the data through statistics and cross tabulation. So there is lots of cross tabulation there. So using the cross tabulation, we are going to compare the multiple variables out there. And non-graphical is there just with the numbers, and then we also have graphical part. So when it comes to the graphical part, multivariate data, it will help you to represent and to depict the connections between two or extra set of data which is there. And they extensively use the graphic in the bar chart or the grouped bar plot, with every group which is going to represent one level, or which is going to represent one level. And yes, sorry for the disturbance in between. So this multivariate graphical is going to represent, extensively it is going to represent the one level or the two level, that is with the cross tabulation. You're going to see the cross tabulation with the graphical representation, which will be very much interesting there. And one more thing, when it comes to the other popular categories of multivariate graphics, it has like the scatter plots are there, where whenever I want to compare multivariate spreadsheet, or multiple variables, I can go for the scatter plot. So the scatter plot is there so that you can conspire the data junctures on a vertical or a horizontal axis to indicate how much one another influences one variable, how much they are related to one another. And another multivariate chart is there. That multivariate chart, which is a visual manifestation, so that it is going to give the connections between the response and the factors in that variable. And then you have the run chart. So the run chart is a kind of a line graph of the data which is conspired over the time. And then you have the bubble chart, which is a technique in the data visualization that will exhibit numerous circles. Bubble, it will be the chart will be kind of a bubbles chart, so that in the two-dimensional conspiracy or a plots. And then you have the heat map. Heat map is a kind of a very interesting one. For most of the exploratory data analysis, many of the researchers and scientists go with the heat map, so which is a visual articulation of the data, where it is going to give the significance which you're getting with the different colors. It will give you the significance by the colors in that particular graph, heat map by the different colors, and it is showing, it will show the significance between the data over there, so that so that you will be able to understand which variable is significant with another variable there, so using the heat map. And this EDA involves like generating summary statistics for numerical data in the data set, and also it can create various graphical representation to understand the data in a very better manner. Okay, so these are the four fundamentals which I'm talking about. And now we are going to see the advanced functional exploratory data analysis using the Python as a tool. So you all know what is, you must know what is Python programming language out, because many of the data scientists, 60 to 70% of the data scientists out of the industries, they use the Python as one of the programming language to explore or to do the data science, like data science tasks and data analysis tasks. So Python, it is a high level and a general purpose programming language, and it helps the programmers to write a clear program to interact with the system and develop clear and logical code for the small and the large scale projects also. So it was created by Hideo van Rossum, and it is an open source as well. Python, in case if you want to practice also, you can you yourself can download the Python version and you can practice with that. So here we are going to use one of the ideally to learn the Python, that is the Jupyter Notebook. That is what I use most of the time. I like Jupyter Notebook, so I always prefer Jupyter Notebook. There are lots of other different IDLEs, so that where you can explore or learn your Python codes and the programming part. So now let us just go to the Python programming. Let me just share the Python programming code to you all. Okay. So here we have this Python data analysis by using the advanced functional exploratory data analysis. Okay, so we are going to go step by step. I'm not going to explain the whole code. So if I take the whole code, it becomes the whole course is being covered in the CDA itself. I'm going to brief out what is happening with this particular data set. So here we are going to take the Titanic data set, a very famous data set, which is there. So we all know the Titanic, the ship which was which sunk, and then that particular data which was collected during that particular study, like who was alive, who was dead, how many people dead, and what might be the reason. To understand all that, they have taken the Titanic data set, and we are using this very famous Titanic data set, and we are going to do some exploratory data analysis here out and show you all with the functions. So coming to the Python data analytics, when it comes here, the first and the foremost thing you will have to do here is first import all the necessary libraries which is required for the EDA. Okay, so most of the time what we will do is we will just import the NumPy, Pandas, Seaborn, and Matplotlib. So these are the important libraries which is required for our data analysis EDA, exploratory data analysis, so that we are importing the NumPy, Pandas, Seaborn, and Matplotlib library. So NumPy library deals most of the time deals with the arrays. Pandas is very good library or a package for dealing with the analysis, data cleaning, uh, or exploratory data analysis. Pandas is one of the best best package when it comes to the data analysis process. And the next one is like import the Seaborn as SNS. So Seaborn library is there, which is going to give you. So before Seaborn, there is Matplotlib. So Matplotlib library is going to give you the basic graphs. It is a kind of a grandfather in the Python. They say it as a very old Python library, which is going to give you the data visualization, the graphs and all you're plotting, right? You will be plotting with the help of the matplotlib.pyplot library. And after Matplotlib, in case if you want to add extra features or beautify your graphs by giving in the labels on the different colors and whatever extra features you want to do. And then we have the Seaborn library, and it doesn't stop here. There are lots of data visualization library. I have also given lots of sessions on the data visualization, especially with the Plotly, which I like personally, the Plotly package, a Plotly library in Python, which is an interactive plot. It gives an interactive plot. If anybody is interested in data visualization, I just recommend that particular Plotly. It is an interactive plot. You can go just take a look by browsing outside and see in the Google or somewhere, so that you will get to understand the difference between the Plotly data visualization, what I am talking about. So it is a kind of a very interactive plots, which will, it's a kind of some kind of a friend is there to guide me in the particular graph and tell me each and every point where it is plotting to. So that is the Plotly library. So, but we are not using Plotly library here, but I just wanted to tell that point here when it comes to the libraries for the data visualization. So these are the important libraries which we will be using, and the set option is nothing but display maximum rows 500 or maximum columns 500. It's just, we are just setting it up before we start the session, start the analysis EDA. And then the next thing which we are going to see here is, first we are going to load the data set. So here the data set, with the help of the SNS, that is a Seaborn library, we have the load data set function. So with the load data set function, we are directly loading the Titanic data set. So in the Titanic data set, I have just given it as df.head. That is nothing but it will give me only the first 5 rows of observation in the data. So if you see this df.head, and we can try to take a look into the columns in this Titanic data set. That is, there is the column which is survived, what is the P class, sex, age, SIB SP, park, fair, embarked class, WHO, adult underscore male, deck, embark underscore town, alive, alone. So these are all the columns which is present in the data, and the observations which are there, in which we have taken only the 5 observations. So in this, there are lots of, it looks, for example, survived and P class. Here are the numeric columns, because we can say numeric columns because it is like 0, 1, 0, 1, 2, 3. But actually they are numeric columns, or what we can find out with the help of the exploratory data analysis. Why I am telling this is because some of the columns actually look a kind of a numeric, but they are categorical. Some might actually be categorical, but they are numeric. So so that way we are going to check out or explore what is the columns, the categorical or the numerical first, and then we are going to check with the target variables and see with the advanced functions how they are doing, automating the things here. Okay, and then if you see, this is the first, we are loading the data set, and the second one is we are just doing the group by. So in the group by, we have grouping by the survived survived and the sex. So how many people have survived and what is the sex who have survived. So we are just trying to group by that survived and the sex, and we are going to get the details. So 0 is not survived, 1 is survived, and then in that female, male and female, in the P class, age, SIBIP, patch, fair, all the columns are included, and we are just grouping by, and then we are doing the frequency. Count is nothing but the frequency, and this is the answer for that. And then df dot tail is also given. So as we all know, head is nothing but the first 5 rows, five rows, and the tail is nothing but the last 5 rows of the observations in the data set. Tail will give me the last 5 rows, head will give me the first 5 rows. And if I ask for the shape of the data set, my total rows in my data is 891 rows and 15 columns. So this is how you explore your data. So when you are working in your industry and when you are given with the data, so your vendor is giving you your data, and then you don't know anything about that data. He's just giving you that file. Once you load it, you're going to explore your data by checking what is the shape of that file, which means how many rows it has, how many columns it has. Okay, and then you're just going and taking a look in the data how the values look by exploring the first 5 rows and the last 5 rows in the data. Once you have checked with that part, that is the main important thing, right? First, as soon as I get something, how much is there in that data, how much rows and how much column, how many columns and how many rows are there in that data, I'm going to check with the help of df.shape. And I'm going to check what is the info in the data, which means it is going to give me the complete information of the data set by giving me the column names, that is all the 15 column names it is going to give me, along with the non-null count. So non-null count is nothing but it is going to give me how many non-missing values are there. It's not how many missing values are there, how many non-missing values are there. So if I just look into this data, I have 891 rows in my data. So in that 891 rows in my data, I can see my survived is having 891 non-null count, which means all my rows are completed without any missing values. And P class is also all the rows are being filled without any missing values. And in the same way, the sex is also there without any missing values. But if I see the age is having 714, which means that there is missing value in that particular age column. Sorry, yes, there is some missing values in this particular age column, because my rows is 891, but if you see the age column, the non-null value, that is non-missing value, is just 714. The rest of the values are missing. That is what you should have an understanding about in the data. Okay, and this way, if you see here, I can get to see that the deck is also having a missing value, as well as the age is also having the missing value. Rest of the columns are all filled with the non-missing values, which means there is no missing value. And it is also going to give me the data type. What is the data type of each class? It is, for example, survived P class is telling me they are the integer class. Numerical data, sex is an object, which means they are coming under the categorical, and then ages are coming under the float. And then we have the Boolean is also there. Adult underscore male is a Boolean type. So like this, we have different types, data types in the study. And what is happening, doing all the steps manually is very time consuming. See, if you see, I'm just doing one by one, info, shape and everything. It's just time consuming. So what if in case I have been given with 10 different data sets to work with, and I will have to do for each and every data set, I should keep on typing the df.columns, df.info. That is a bit of time consuming for me, right? So that is why we are going to see this particular advanced exploratory data analysis, where I will be using a function to do or to automate the things which is here. So I have just proposed, like, we can create a function to automate the steps which we are doing. And by developing a function, I will be developing a function, and I can easily repeat the process in the very consistent and efficient manner without the risk of manual errors also. So there will be no manual errors. In such a way, I am going to work on this task. So I am like confident that this approach will not only save time also, but also resource, and improve the overall accuracy of the and the quality of the data. So if you see what is the df.columns, it is going to give me all the columns list here. And then if I just go with the df.describe.t, it is going to give me the only for the numerical data, it is going to give me the what is the mean, what is the count, standard deviation, what is 25%, the in quartile ranges, Q1, Q2, Q3 ranges, and the minimum and the maximum also it is trying to give me. And then is there any missing values or not? I'm going to ask the data, is there any missing values or not? So as an expert, so as I have been with most of the data, I can tell with the information itself there is a missing value. But you want to know, for example, let's say you are not able to understand here, you can also try to get the understanding with the help of you can also try to get the understanding with the help of is if the df dot is null dot value dot any, if any missing value is there or what you're going to ask, and then you're going to get it as true, which means that there is missing value. And if you want to know what is the missing, which column is having the missing value, and how many missing values are there, like what all the missing values are there, that you can get it with the help of df dot is null dot sum. So if you get it in, if you just write this particular function, you will be ending up with getting the what is the missing value. So as I told you, with that info itself, I found out that there was missing value, but this is the count. So these many missing values are there. That is age, it is having 177 missing value, and in the deck column there is 688 missing values. Okay, and in the deck column there is 688 missing values. So I am finding out with this particular is null is sum function. So I am just going to automate all this with one function here. Okay, I'm going to automate all this with one function. So next time I'm just going to give in the different data. I'm going to give in the data set name differently with the name of the data frame, and then I am going to work on it. Okay, and then I am going to work on it. So here I am going to derive a function, develop a function which is called as check underscore df and data frame comma head, and I'm going to put all my print of shape or data types or head or tail or descriptive, whatever I want to find out, whatever we have done step by step, one by one in each shell. So this is one shell. In each cell, whatever I have done, I am going to do it automated here. Okay, I am going to automate it here in a very good manner. So this is a automation. This is how I do the automation. I have put everything in this particular function, and then I am going to do the check underscore df. Check underscore df is a function name. So if in case the prerequisite for this particular event which we are conducting is that you should have a good understanding with the program, so that I don't have to explain more here. So if in case you know what is this define function, define we use to create our function, user defined function. If you want to do, we are creating it with the define function check underscore df. I will be just calling the check underscore df function. This is a calling function, and within the parenthesis I'm going to give the data frame. So the data frame which we are going to deal with is df. Why? Because my data frame which I have downloaded, the Titanic data set, is in the variable or identifier named df. So I am taking this df here, and then I'm going to give that df inside my function. So in case I'm dealing with another data. Okay, in case suddenly I'm dealing with a different iris data set or some other data set which is given to me in the company, so I don't have to write all these again and again. So in case if I have this ready made with me already, so I will just use this check underscore df. Okay, check underscore df, and I will just keep check underscore df, and within the parenthesis I will just give the variable, like I will just give the variable or the identifier what I have used to download the data set. So then it will automatically give me all the details in one output. I don't have to do it separately like this what I have done. So next time if I do it, it is very easy for me. I just give this function and the name of the function and what is the data set variable which you have defined. It is going to automate me what all the things is being done. Okay, so this is what we have done. It is an overall view what we have done, and we have used this particular check underscore df function. So in the same way, I can also do the another different exploratory data analysis in the same process how I have done it with this particular the overall part. So the overall is nothing but the overall information, what is the shape, data types, head, the tail, describe. In the same way, I want to deal with the categorical variables, I want to deal with the numerical variables, I want to deal with the target variables. For everything, I can define a function which is called as advanced functional exploratory data analysis. So that is what we are discussing today, right? And now the next Python data analysis for the advanced functional data exploratory is for the step 2, that is categorical variable analysis. So in the categorical variable analysis, we looked at the big picture of our data, right? What is the details of the shape and everything. Now we are going to go in a deeper analysis where we will gain the insights that can guide our decision making and help us move forward in our analysis. So I'm looking forward to digging into the data and discover the variable insights over here. So we know this particular info function, we have used the same info function, and here we are using I'm doing something that automatically selects all the possible categorical variable in the data set. So this particular function which is there here, it is going to select me the categorical function, the object, and the boolean, all the category, object, boolean, without the numerics, what all columns are there, except the numeric column, what all columns are there. So in that point of view, we can see that sex, embarked, class, who, WHO, who is their, adult underscore male, deck, embark underscore town, alive, alone. These are all the categorical variables. And sometimes some of the numerical look like numeric, but they are categorical. So I want to explore that one also. If you see survived, P class, SIB, SP, PARC. So if I take a look into the data set, SIB, survived, SIB, here, survived, SIB here, SIBIP, Parch, and everything, it's like numeric, right? 0, 1, 1, 1, 0. It's in the numbers, it is numeric, but it is actually not numeric. They are like 0 is dead and 1 is alive. So when that is the situation, so you should try to understand what are the variables which looks like numeric, but they are actually not numeric. They are categorical variables. So when I want to find out that particular, I have used this particular number, but that is numeric, but it is categorical. So I have used a for loop function here. So, and by using this, I found out that survived column, P class, SIBIP, and Parch column, they are categorical column, but looking like numeric. And I am trying to also explore the exploring which seems categorical, but they are not categorical. Sometimes my categorical, it looks like categorical data, but it is not a categorical data. So during that situation, I am also checking if that is also there, but I found out that there is nothing like that. And then the final categorical columns which I have found out in the study was all these column along with survive, P class, SIBIP, and Patch. The first time when I checked for the categorical column was only this much, only these many columns were given in the output. But the survive, P class, SIBIP, and Patch are also categorical column, but it was but here it was a kind of, to look at it was a numeric, but it is actually a categorical column. So this is a complete detail. So I'm functionalizing it to put it into a proper function, so that I'm creating a cat underscore summary function. So cat is nothing but categorical underscore summary function, and I automate this. So next time I have this data, I just put this for column in the categorical columns, and then I use the data frame, and each of the values will be coming with the plot figures. So here for all the categorical columns, for the survived sex, male and female, what is the male count, what is the female count, what is the ratio, each and everything along with the ratio, because I have defined it in my function itself with the ratio I want my graph to be plotted. So then it is being giving all my ratio of then the embarked column is being given, class columns information, first class, first, third class, first class, second class is there in that column, and in that WHO column there is man, women, and child unique information. These are the unique value. See, in simple, I am finishing the unique values also. I am not doing the value counts also here. In adult male column, true or false is there. Then it is like 300 and 537 and 354. And then the deck column, in the deck column, these are the values which is there in the deck column, like C, B, D, A, E, A, E. And then we have the next one is in the embark underscore town column, that is Southampton is there, Cherbourg column is there, Queenstown is there. From these people, from these towns, these are the numbers of the maybe the people who travel there. And when it comes to the alive column, who was not alive or this much in number, who was alive was this much in number. So easily I am able to explore in one particular step. I haven't done anything. So this is a different, just to make you all understand, but I am functionalizing in a single step. So next time I don't have to write the above steps here and check with the things. I can directly just give this one particular step and I can get the output in the form of a graph and visualize it easily. The same way how we have done for the categorical, I have also done for the numerical variable analysis. When I tried to check what are the numerical variables here, age and the fair was the numerical data here, because the rest of the columns all went in the categorical column and the numerical column age and the fair is left out. So for that, they are just trying to check. For example, they are also trying to check for the columns in the other data frame, like whether they are not looking like numeric but they appear numeric, or what they are trying to check. And if you see, the final age and fair was the numeric column in that particular data set. I'm briefing out the study for you all. Okay, and then the numerical summary, I'm going to get the numerical summary with one numerical underscore summary function. And if I put it there with the graph for column in the numeric underscore summary, numeric underscore columns, and then numeric underscore summary, the data frame variable, data frame df, I'm just giving. And then if I see, I will get the complete age. What is the mean for the age? What is the mean, median, standard deviation, minimum, and all the different percentages, 10, 20, 30, minimum and maximum, along with the graph and the frequency count. And the same way for the age also, I'm getting it. So the numerical study is also being explored. Once the numerical study is being explored, then I am going to do the same functionalizing, advanced functionalizing. That is last step to capture of the variables, generalization of operations, and the target variable analysis is also done. So here I am using this particular whole grab the column names function I'm using, so that this particular function, it goes to give me the categorical. Okay, it gives me the categorical names of categorical, numerical, and categorical, but cardinal variables in the data set and each of the everything. So with this codings and whatever is there, I'm going to summarize it and grab all the column names. So here observations, total observation is 891. The variables are 15. Categorical columns are 13. Numeric columns are 2. Categorical, but their character is anything like that? No, there are 0. Numerical, but they are categorical. Yes, 4 columns were numerical but categorical. So that is the value. So I have grabbed all the column informations and the details in the data in one particular graph defined function. And then if you see the observations here again, it is the same thing which has been done above, just to extra note which is being given there. And then categorical underscore summary, I can, without the plot also, the one which we have seen with the graph, without the graph also, I have created a function. Without the graph, I have created a function. Earlier which we saw was with the graph. And that way we are going to explore. So what happens is, next time you have any new data set, you don't have to write the codes for like each and every code to find out the categorical values or the numerical values. You can use these function which is already there, and you can do the step automatically. In the place of the df, you're going to give your new data sets variable and you get the complete information automatically. You don't have to go and select or check or explore separately for each one by one. And the last step is the target variable analysis. So for the target variable analysis also, we are doing it. So the purpose of conducting the target variable analysis mainly is to identify the relationship between the target variable and the numerical and categorical variable. What is my target variable and the numerical and categorical variable? I want to find out the relationship. That is what my main goal when it comes to the exploratory data analysis. So the main aim is to gain the insight into the factors that affect the emergence of the target variable. So the context of the Titanic data set, the survive variable serves as our target variable. How many people have survived in that Titanic Titanic ship sunk? And then to gain a better understanding of the determinants of the survival, how many people have survived, we need to examine the relationship between our target variable, that is the survived column, and the numerical and the categorical variable. So that will involve the analyzing the pattern and the trends across the variables. So it will discern the correlation which is existing between them. So then for that reason, we are just keeping the target mean from with all the categorical variables with the survived column. So along with the survived column, we are also taking the target mean of the sex embarked, all the categorical column with the survived column. And then we are going also comparing the category survived column with the numeric column separately. And then we are trying to find out the relationship between the categorical and the numerical with the target variable, that is survived. How many people survived or how many people have not survived the Titanic ship sunk. Okay, so with this, here our exploratory data analysis, that is advanced functional techniques in the EDA, is complete. And that is the end of our event. So if there is any doubts from your end, you can put in the questions.